Welcome everybody. This is the continuation of the previous lesson. If you have not watched that, I would suggest you to watch the previous video, and where I have shown you how to get the area of the triangle. And during the process, I already mentioned to you that the question is part of a mega problem. Now this is the second part of the question. In this case, we are expected to find the radius of the smaller circle and subsequently calculate the area of the smaller circle, and we are not being given anything else. So what I wish to do is, I would like to approach this in a different way. Now what I wish to do is, I would like to drop a tangent from the center to the point of contact of these two circles. Now if I were to take this as O, and if I were to draw a line from O to, say, this is the point of contact, roughly this is the point of contact, then this would make an angle, by tangent theorem, this would make an angle of 90 degrees with the tangent. So I have a 90-degree angle. Now what I wish to do is, I would like to join O with C. So they are the centers, and whenever the circles are in point of contact, a line through their centers would actually connect them both. In other words, if we were to draw a line through this point of contact, then that would go and hit their centers. That's again a property. So that's exactly what I'm using here. Okay, so I have a right triangle, so let me take this point of contact as P. So OPC, now this distance is 4 units, this distance is 5 units, it's given in the question. So this entire length is 9 units, this distance is 4 units. So I will apply Pythagoras. Let me apply Pythagoras over here. So consider triangle OPC, it's a right triangle. By Pythagoras we get, so what do we get by Pythagoras? OP squared plus PC squared is equal to OC squared. OP squared is 4 squared, PC squared, you need to find that. OC squared, 4 plus 5, 9 squared, 81 negative 16. So this will give me 5, 7, from 7 you take away 1, you get 6. So this is going to be 65. So PC squared is 65. PC is root of 65. So I have got this to be a square root of 65. Okay, fair enough. Now I would be applying the same principle. What is that? If I were to take this as, say, some S, and from, or I would say through S, I am drawing a line to meet the tangent. So that would mean that this would make a angle of 90 degrees. Now since these two circles are in contact, I can connect their centers. So the centers are connected. So now I have the following triangle, and if I were to take this to be of radius R, then this is what is required. So this is R, this is R, and this length I know it's 5 units. So since SPC is a right triangle, I can apply Pythagoras. So let me write that down here. Consider triangle SPC. So by Pythagoras we know that, so what do we know? SP squared plus PC squared is equal to CS squared. So CS is 5 positive R whole squared, and PC squared, PC is this one, so it's going to be 65 plus SP. I'm taking SP to be of radius R unit, so this is going to be R squared. So now we need to get the value of R. So R squared plus 65 is equal to 25 plus 10R plus R squared. So you get R squared being cancelled, so 65 negative 25 is equal to 10R. This is going to give me 65, 40 is equal to 10R. Therefore R is equal to 4 units. So this is what I'm getting, the value of R to be as. So subsequently we can calculate the area of the circle. So area is pi into R squared, pi times 4 squared, which is nothing but 16 pi square units. So this is a nice question. Apparently if you were to watch the figure, this is 5 units, this is 4 units, so the entire side is 9 units. This is 5 units, 4 units, the entire side is 9 units. So the figure shows it to be a small circle, a smaller circle than these two circles. Apparently we find the radius to be equal to 4 units. So in other words, just because we see the figure to be a smaller circle, we cannot conclude that the radius would be the smallest value of all the 3 circles, because apparently over here we get R is equal to 4 units to be the radius. Over here we have found R is equal to 4. And another important condition that we have utilized here is that we have assumed a tangency from the big circle to the 2 other circles. So that is a very important assumption that we have taken for granted. So that has to be also brought into consideration. And as we all know, this results in isosceles, and that would mean this division is going to be equal, because when you drop a perpendicular from the vertex to the base, the division have to be done at 90 degrees. So the division is actually 90 degrees if you were to see this figure. So that would mean the division is equal. So we have taken those parameters, and that is the reason that we have arrived at this particular solution. So please like, share and give your comments, and until we meet again, enjoy your day. Thank you.